Understand the very important topic of the modern physics, that is alpha, beta, and gamma decay. Now, before going ahead, okay, in this alpha, beta, and gamma decay, one should know what exactly a radioactive decay is. So, in our usual life, in our casual life, we know what actually decay is. So, in biodegradable substance, we can see like things get rotten and then they get damaged, just like an apple. Look at the screen on your left hand side. You can see a fresh apple is there which is started to spoil, and after some time, after emitting various things, okay, after emitting gases and then there are germs, then it gets spoiled. Okay, so this whole process is called as decaying. Similarly, like in atoms also this process takes place. Now one should ask, why decay, why things get decayed, and especially why an atom gets decayed. So let me tell you. First of all, like in universe everything wants to get stable, okay, and this is intrinsic property of the nature. Now, since the atom wants, like there are different kind of atoms, not exactly one kind of atom, there are many atoms, okay, and each of them want some stability. They want to minimize their energy difference, their energy gaps, their energy level, okay, so they can get into the normal state. Now on the right hand side of your screen, you will be observing there is atomic nucleus, okay, which is emitting these three particles: alpha particle, gamma ray, and beta particle. All right, so this all is done because our atom wants an stability, and this is a very sudden process, okay. This is very spontaneous. You can't predict which particle is going to decay, or sorry, emit, which particle is going to emit at first. Now the particle, like when this decay comes, these are the three major particle: alpha particle, gamma particle, and beta particle. Now we are going to understand a little bit more about this particle, okay. So as said, first I will tell you about the alpha particle or alpha decay. Now all these namings, they are very, you can say, touched with the nature. In nature we find, we categorize the people, okay, on the basis of their behavior, like this is alpha, this is beta man, and this is gamma man. Similarly in science also, the particles are they get differentiated in the following manner. Alpha stands for the particle which has highest mass. So at the initial stages, when scientific experiment were carried on, people don't know what exactly this particle is, so they termed this particle, which was a very heavy particle, as alpha particle because it was heavy. But after later, like when science grew, then it was found that it is nothing more than a helium, okay. So when you remove the two electrons from the helium, you will have an extra charge 4 on it, and this is called as alpha decay, okay. Now there is a generic equation. If there is a decay, okay, which is alpha decay from any particle like a x z, where this is atom, a is atomic mass, z is atomic number, and if atom is emitting this particle, so this is the generic equation. You can see there is a reduction of 4 in mass and reduction of 2 in atomic number, okay, and this is called as alpha decay. In the later sections of this slide, I will tell you many more theoretical part about this alpha decay, but first let us consider this beta decay as well. So in beta decay, first of all, this beta decay is of two types. The first one is beta plus decay, and then other one is beta minus decay, okay. So if any atom, the same atom AXZ, is emitting or you can say it is following the beta positive decay, okay, then a positron is released, okay, and a neutrino is released. So neutrino, we resemble it by this, and positron, let me tell you what exactly positron is. So it is basically just like an electron. Positron is having a plus one charge, okay, and it has a zero mass. Now if from an atom there is a plus one charge, okay, going out, so the remaining charge is in the atomic number will be z minus 1, okay. This is their configuration. In the similar manner, in beta minus decay, okay, so here the positron is released and this is neutrino. Here antineutrino is released, and a negative charge, you can say electron, is emitted and the atomic number gets increased. Okay, now we can say this is analogous to electron, but positron is not electron. Okay, we will discuss on this, okay, later on, exactly what they are. Now coming back to the last decay, that is gamma decay. Now you might have saw the Hulk movie, okay, and there they have described like this: due to this gamma emission, it became Hulk. Okay, very strong and very powerful person with a heavy biceps. So gamma emission, when you talk about, exactly gamma rays are there. Okay, so if any atom emits this gamma, what I will say is a ray. So let me write this. So suppose this is my atom, let me make it by X as a general notation. Okay, if somebody is emitting a gamma emission, then there is no change in mass, no change in atomic number, because it is, our atom is in excited state, and after releasing the energy, so energy is released in gamma rays form. All right, so mass is not changed, the gamma has no mass, no atomic number, and similarly, like the atom is also unchanged. Now in the upcoming slide, I will be telling you more, like how the reaction takes place, what are the reactions. I will give you n number of example. I will tell you the theoretical differences and the practical differences as well. Thank you.